Statics is that branch of mechanics that deals with bodies at rest under the action of a system of forces or torques, or both forces and torques. We must remember that a body in equilibrium is not necessarily static. It rather means that the body experiences no acceleration, either linear or rotational. Let's discuss a little bit of rotation of a body and a moment of a force. Here's in the plane of the screen a wheel pivoted at the center. A force of magnitude F is applied to the wheel at the center. Will the wheel rotate? Our experiences readily say that it will not rotate. Let's now apply the same force at a different point on the wheel. Will the initially static wheel rotate now? Yes, it will surely rotate now. Let's now shift the point of action of the force to the edge of the wheel as shown in the diagram. The wheel will have a greater rotational acceleration than in the previous cases. What happens if the same force is now exerted on the wheel at another point as shown in the diagram? Let's produce the line of action of the force and check whether it passes through the pivot. Well, we see that the line of action of the force passes through the pivot. Hence, the wheel will not rotate. Let's change the direction of the force acting at this point. In this case, the line of action does not pass through the pivot. Then, the initially static wheel will rotate. Thus, the rotational effect of a force depends on the following. Number 1. The magnitude of the force. The greater the magnitude of the force, the greater the rotational effect. Number 2. The perpendicular distance of the line of action of the force from the axis of rotation. The perpendicular distance of the line of action of the force from the axis of rotation is known as the arm of the force. Let's now get familiar with the concept of the moment of a force. The moment of a force is the tendency of the force to turn a body about an axis, and its magnitude is measured by the product of the magnitude of the force and the force arm. The moment of a force is a vector directed along the axis of rotation. The specific direction can be determined from the right thumb rule. The wheel is in the plane of the screen. If the wheel is initially static, the moment of the force tends to rotate it in the clockwise direction. Thus, according to the right thumb rule, the moment of the force in this case is directed into the plane of the screen. Newton meter is the SI unit of the moment of a force. Despite being acted on by an externally applied force, the wheel does not have a linear acceleration. Is it a violation of Newton's second law of motion? No, not at all. The wheel must experience another force equal in magnitude and opposite in direction. This begets the concept of couple. What is couple? A couple is a set of two equal and opposite forces that have different lines of action. The perpendicular distance between the lines of action of the two equal and opposite forces composing the couple is called the arm of the couple. The moment of a couple has a magnitude equal to the product of either of the forces producing the couple and the arm of the couple. The moment of a couple has a direction along the axis of rotation. There are three basic properties of a couple. To begin with, a couple produces or tends to produce only rotational motion. In addition, a couple cannot be replaced by a single force. To conclude, a couple can be shifted anywhere in its plane of action. Let's now know the general conditions of equilibrium of any number of coplanar forces. The first condition: the vector sum of all the forces must be a zero vector. The second condition: the vector sum of all the moments of forces must be a zero vector. Equilibrium under two forces. If two forces acting on a body keep the body in equilibrium, it follows that the forces must act along the same line but in the opposite directions, and the magnitudes of the forces must be equal. If these two equal but opposite forces do not act along the same line, they will produce a couple causing angular acceleration. Equilibrium under three forces. If three forces acting on a body keep the body in equilibrium, we get the following from the general conditions of equilibrium. To begin with, the forces must be coplanar. Secondly, the three forces must be concurrent. In addition to this, one of the forces must be equal and opposite to the resultant of the other two. To conclude, the three forces can be represented in magnitude and direction by the three sides of a triangle taken in order. This is known as the triangle of forces. Also, each force is directly proportional to the sine of the angle between the other two. The following is the expression for the position vector of the resultant of several parallel forces, like or unlike or both. The center of mass is a hypothetical point at which the entire mass of an object may be considered to be concentrated to visualize its motion. This is the expression for the position vector of the center of mass of a system of particles. The coordinates of the center of mass of a continuous rigid body are expressed as follows. The center of gravity is a point from which the weight of a body or system may be considered to act. In uniform gravity, the center of gravity is the center of mass. The following is the expression for the position vector of the center of gravity of a system of particles.